So really, I think the key is that you'll want to make sure that the facility has, of course, the right infrastructure to provide that capability needed. But you have to decide how you're going to integrate the classical components. I think that's the most critical. We didn't talk about it today, but to actually run error correction in a quantum computer is going to requires a massive amount of classical resources. So you need FPGAs and CPUs and memory and fast buses for networking. And so the joke is that you need a supercomputer to run the quantum computer if you want it to be fault tolerant. And it's kind of a funny joke, but it's actually kind of true. And so in the beginning, likely what will happen, because it's simpler, is that you'll have the classical supercompute, you'll have the quantum compute over here, and there'll be some networking software, but they're going to be kind of individually controlled by a user. They're going to have access to the quantum compute and the classical compute with a short latency because they're in the same facility. But really the way to get the benefit of hybrid quantum computation is when you do a co-design. You design the data center, you design the supercomputer to be a hybrid quantum compute. So you need to be able to leverage your classical resources, not only to do classical computations for the user and their algorithm, but to run the quantum computer and do error correction. So that's where you're going to see the greatest efficiency when those are designed together. It's more complex, but it's really exciting, and you'll see much better efficiency. You'll see much better performance, and the users will be able to really tap into the power of the quantum processors as well as the classical processors.